Hi, everyone. I'm going to be providing a lecture for week 3. This week will involve working with VLANs and trunking. So for this lecture, I'm going to be using Scott Cunningham's PowerPoints from when he created this class. I'm also going to give another demonstration of VLANs and trunking. It'll be very similar to the one I already gave, but this will basically be your lecture for this week. So basically we'll be talking about VLANs, VLAN tagging, trunking. It's not listed here, but also we'll talk about subnets and the iOS VLAN commands you need to use. VTP is something that's not really covered in this class, but we'll briefly discuss it here as well. So all this semester, you've been working with LANs. Now, LAN consists of all the hosts in a single broadcast domain. Now, as you recall, a single switch is a broadcast domain. Actually, multiple switches connected together comprise of one broadcast domain or LAN. Now, there's a way to split switches up into multiple broadcast domains, and that's with using what's known as a VLAN. So a VLAN is basically a LAN, or it's basically a virtual LAN. Instead of having like physical switches and computers connected to each other and that comprising of a single LAN, VLANs create digital or virtual divisions in the broadcast domains on the switch. So you see you have these two computers here in VLAN 1 and two computers here in VLAN 2. Now these two ports on the switch in VLAN 2, that comprises of a broadcast domain. And it's the same with VLAN 1 and these two computers. So without VLANs, all ports on a switch belong to the same LAN, as I just said. But with VLANs, a switch can support one broadcast domain per VLAN, or basically one VLAN per port. So you can actually support a single VLAN or broadcast domain on every single port on the switch. So there's multiple reasons why we would use VLANs. One is to organize the network logically instead of by which hosts are plugged into the switch or which switch. So if you have like an office in your company that has like you have sales and marketing in one or two rooms and you have like research and development in another, you could use VLANs to separate the traffic, assuming all those computers that connect to this to the same switch. You could break up traffic logically by department. So VLANs also have another purpose. They also reduce the size of broadcast domains to reduce broadcast overhead. So broadcast domains, basically, as you know, or broadcast frames basically are forwarded to every single device in a LAN except from the sender. Now, when you have a lot of that going on, especially with ARP, that consumes a lot of bandwidth. So that's why VLANs are also helpful here because they reduce the number of devices that a broadcast frame goes to. So VLANs also enforce security by restricting sensitive hosts to specific VLANs. So for example, your research and development devices, you can have them all in the same VLAN to keep traffic from other devices, to keep that traffic separate from other devices. So VLANs also reduce the workload of STP, spanning tree protocol. We'll learn about that later in this class. But basically, all it does is it's used to prevent broadcast, or it's used to prevent broadcast storms in a multi-switch network. So finally, VLANs separate VoIP from data traffic. Basically, it's the same thing as organizing network logically by hosts. So VLANs basically the basic gist of VLANs is to divide network traffic. So also VLANs have what's known as VLAN IDs. These are 12-bit numbers between 1 and 4094. So the lowest and highest VLAN IDs are excluded. So like VLAN 0, VLAN whatever is after that. Typically VLAN 0 is not something there's no such thing as VLAN 0. So a normal range of VLANs is 1 to 1005. Basically, in your work, you're going to be using numbers between here. And there's extended ranges. That's an extended VLAN range, not really used here in this course, but this is the range you're going to be using here, between 1 and 1005. So subnets and VLANs. Now, as you recall, subnets deal with layer 3 traffic, while broadcast domains and LANs are layer 2. So as you may recall, all the hosts in a single LAN need to be in the same subnet. Such is true with VLANs. So hosts on a single VLAN must be in the same IP subnet. On the other hand, hosts on different VLANs must be on different IP subnets. Now, if you see my little class example I'm going to be using later in this lecture, I have VLAN 10 here and VLAN 20. Now notice that these two computers in VLAN 10 are in a different subnet compared to VLAN 20. So that's very important because VLANs already separate traffic to where hosts in different VLANs can't even communicate with each other anyway. So you need to use different subnets. You don't want to repeat IP addresses. So that's why we use different subnets in different VLANs. So hosts on different as I said, need to be on different IP subnets. So for hosts on two different VLANs to communicate, a router is needed, even if the hosts are plugged into the same switch. So multi-layers or layer 3 switches are also an option here. So there are actually switches that can run both VLANs or layer 2 and layer 3 traffic. And routers here actually do allow VLANs or devices in different VLANs to communicate with each other. It also allows devices in different LANs to communicate with each other. That's the purpose of routers. So if you look here, we have an example here of a layer 3 switch here. So this is basically the logical part. That's the physical. Actually, that's a route, I believe. So basically, we have VLAN 1 here. We have the computer Fred. It wants to send a packet to Wilma. So this packet goes from Fred PC through the switch to the router. Now the router actually takes that frame, sends it to VLAN 2, and that frame goes to Wilma. So actually, the source, what's interesting here is that the source packet, or layer 3 packet from Fred has his computer's IP address, and it has Wilma's IP address as well. That's the destination IP address. That's how this router here knows to send the data to the Wilma PC. So you may find that when you do the show running config command, you won't find any VLAN information. That's because VLAN configurations are stored in the VLAN.dat file in Flash. So in order to see VLAN information, you need to use the show VLAN command or show VLAN brief. I can actually show you that right here. So here's IOU2, the second switch. We're going to do show running config. Show run is short for that. So we scroll up, see a bunch of version information, the host name, a bunch of other miscellaneous stuff, but still the interface information, the telnet stuff, but we don't see anything about VLANs. So show VLAN. That's how we see VLAN information here. Let me extend that out a little bit. So that's our VLAN information. We haven't configured any VLANs yet on here. VLAN 1 is here by default, as you notice, and all the ports on the switch are connected there by default. Now we'll be changing this soon, but that's just to show you that. So creating a VLAN. Creating a VLAN is actually pretty simple. One way you can do it is typing the VLAN command. So VLAN and then type the VLAN ID like VLAN 1 or 2, I'm sorry, VLAN 2. Then you can name it. You can name it sales and marketing, research and development, or whatever you want. Whatever makes the most sense. So VLANs can be named. You will actually be naming VLANs in your lab assignment. So then you need to configure interfaces for VLANs. So you can type the interface name or the interface range. So interface range and then like E0/0 to 3. And then you type the command switch port access VLAN 2 or whatever VLAN ID you need. Interesting here is that you can actually skip this step here by just configuring the interfaces for the VLAN. The switch will automatically create that VLAN if you do these commands down here. It's a little shortcut. However, you won't be able to name the VLAN from here. So a VLAN configuration example is similar to the other one above, but you note that there's two ports here that are connected to computers that are in the same VLAN. These ports are configured for VLAN 3. These ports here, 13 to 14, are VLAN 2, and ports 11 and 12 are VLAN 1. Now, you'll be setting up a VLAN configuration in your lab. You'll actually have like 8 computers and 2 switches. You need to configure the ports to the correct PCs or VLANs. Here's an example of configuring a VLAN from the terminal. So here's the name. So here a VLAN is being named VLAN2, and then Fred's VLAN, and then exit. And then another command ran, interface range, as I was talking about, fast Ethernet E, or 0/13 to 14. That's 2 ports there. Then you say switch port access VLAN2. So here's an example of show VLAN brief like I showed. And here is the VLAN listed right here. It has its ID, its name, status, it's active, and then it's the ports that are configured to the VLAN. This is a good way to review your work as you're working on the VLAN lab. So protecting unused switch ports. So basically, when you're in an enterprise network, you don't want to have any more ports open than you need. This is because if you have open ports, hackers can actually take advantage of that and connect to your network. That's really bad. So that's why we administratively shut down ports. So if you've noticed in your labs that you might have noticed there's status protocols in the show IP interface brief and other shuts commands for interfaces. Administratively shutting down a port basically completely shuts it off. You can turn it back on, but in administratively shut down status, it can't be used for anything. It can't allow traffic through, and that's good for security. And this setting also prevents trunking from being negotiated, which is a topic we'll discuss later. Also, this is another thing you need to know here. In addition to that, this switch port mode access command, you'll need to use that in your lab. It basically keeps a port from being used for trunking. When you're using when you're using ports that connect to computers, you don't want them to have the trunk. You don't want them to be able to negotiate trunking. So you want to make them access ports because that's what they are. They are there for computers to access the switch and other computers through the LAN. So you can actually take these shutdown ports and these non-trunking ports and assign them to an unused VLAN, like for example, the native VLAN, VLAN1. And that's a good security practice, by the way. An interesting thing here is that VLANs can actually span multiple switches. So for example, if you look at my configuration again, you notice that VLAN 10 and VLAN 20 both span PC1 and PC2. Now, we don't use multiple cables for this. We just use one cable between IOU1 and IOU2. So the question is what happens when you have this kind of configuration? Well, we need a little bit extra data. So when a computer sends data to another computer on the same VLAN but on a different switch, the first switch that's receiving the communication, it needs to know which VLAN to send that traffic to on the other switch. So that's why trunking is used. Well, let me explain this here first. So LAN spans multiple connected switches unless there's a router between switches, as I discussed at the beginning of this lecture. So VLAN needs extra data to span switches. VLAN IDs identify VLANs, like we did, like my example showed for VLAN 10 and VLAN 20. So frames are tagged with a header containing the VLAN ID, so that recipient switches know which VLAN frame that traffic is for. Multi-switch VLANs require VLAN trunking. Here's an example of VLAN trunking. So there's one cable between two switches. There's here's 4 computers in VLAN 1, 4 computers VLAN 2, 2 each on different switches. So when one PC from VLAN 1 sends out an Ethernet frame, it reaches the switch, and that port or that Ethernet frame has the VLAN ID. And with trunking, the switch sends it through the trunking cable and keeps track of that ID. So when it reaches switch 2, that traffic is forwarded to this PC in VLAN 1 because it's in VLAN 1. So this is just another example with, it's basically to show you that logically these two computers are in the same LAN, even though they're on different switches in the same VLAN. So these are trunk status. These are the status messages for trunking. So basically, these messages here let you know if a cable can be used for trunking or not. This is important for troubleshooting. We'll discuss this in the next module, but So access mode basically prevents any trunking happening from whatsoever. So you see the status, so two switches, so two ports on two switches, or yeah, two ports and two switches. These each of these ports can have a different trunking status. So for example, if one side has access mode or is in access mode, but the other is in trunking mode, that brings up an error. You can't forward anything from that cable. So when one port is in access mode, another is in what's known as dynamic auto. Basically, it passively waits for the other cable or port to negotiate trunking. That thing is going to remain in access. But no matter what, if one port is in access, both of them are going to have access, or basically going to function as access ports. Dynamic auto, as I mentioned, is basically a trunking configuration. Basically, it waits for the other port to initiate the trunking negotiations. But if the other port is access or dynamic auto, those ports are going to act like access ports, and no trunking is going to happen. However, if you set up the explicit trunking mode or dynamic desirable, then trunking will occur. Now, with trunking, with the exception of another port having access mode, with one port has trunking and the others have either a dynamic mode or explicit trunking mode, the port or the cable is going to act as a trunking cable. Finally, dynamic desirable, this actively initiates or actively looks to initiate the trunking mode. So if one port is access but the other is dynamic desirable, no trunking will occur. However, the other three statuses will allow for trunking. So keep this table in mind, especially as you work in Module 4. This is going to be very important for troubleshooting. So VLAN encapsulation, there's two types of VLAN encapsulation. One is ISL. It's just a Cisco property VLAN protocol. We don't use it here. You can kind of ignore it because we don't use it in this class. It's not very good. Actually, if you use it, you actually will you'll very likely prevent the switches from trunking whatsoever. We use instead the 802.1q protocol. It's an IEEE standard VLAN protocol. Basically, what this does is it inserts a 32-bit tag into the Ethernet header. This tag actually contains the VLAN ID. If you see here, this tag, it has the priority, it has the type, and it has the VLAN ID, 12 bits, as you recall when I discussed VLAN IDs. But yeah, basically all you need to know is this tag 802.1q is a protocol that adds tags to Ethernet frames for when they go through a trunking cable. So there's the concept of a native VLAN. So unlike ISL, 802.1q supports one native VLAN per trunk. Typically, this is VLAN 1 by default, but yeah, as I said here, but native VLAN frames are not tagged. What's interesting is that if you have two switches and they have computers assigned to VLAN 1, the protocol actually won't tag it. So those basically, it is assumed, so basically switches assume that VLAN traffic is going through the native VLAN unless a VLAN tag is put on. So the native VLAN basically is not tagged. Any traffic going from and to the native VLAN is not tagged. Also, this is very important because it helps support switches that do not understand VLAN tagging. That's why the native VLAN helps with that. So the allowed VLAN list. I don't think you're going to be using this well, actually you will, I think, towards the end. It's just a little thing, but basically you can actually control which VLANs can use a trunk. So for example, in my example, if we had like a third switch and we had VLAN 30, we could actually prevent this trunking cable from taking anything from VLAN 30. So actually all VLANs are included by default. In a trunking cable, it'll accept everything by default. So you can actually do the show int trunk command to see which VLANs are allowed for a specific trunking cable. So you can also control with the switch port trunk allowed command to control which VLANs are allowed through a trunking cable. So finally, the VLAN trunking protocol VTP. Manually configuring VLAN configure. You can actually manually configure VLAN information on your switch, but VTP is a protocol that you can use for VTP allows you to do manual or allows you to automatically assign VLAN information to switches. So basically it runs in different modes. This stuff isn't quite important to this class, but if you want to look at it, you can look at this PowerPoint later, but basically you can have like a computer, like a server, and then it sends out the VLAN and trunking or the VLAN information to switches. So basically, it automatically forwards that configuration information to the switches without you having to physically connect to the switches to configure that information. So that's about it for the lecture. Now let's go on to the demo. But before that, let's go over my command guide. So as you see, as I already mentioned in my previous lecture, I create command guides for most of the modules. These basically contain all the commands you need to work on the assignments in this class. Now, there are some new commands for this module. There's actually quite a few, but the ones I'll be going through in this lecture are these. So the first step when you're going through lab, you want to configure the switch ports to be access ports. So you can pick int range and then the interface range, like this, for example, int range E0/0 to 3, then switch port mode access. Next, you want to assign the interfaces actually you want to create the VLANs because you need to name them. So you type exit and then conf t, type VLAN, the VLAN name, or the VLAN ID, I mean. And then you type name and then you give the VLAN a name. Finally, you assign the interfaces to the VLAN. Once again, the int range command is used, then switch port access VLAN, and then the VLAN ID. So one other thing you need to know how to do is to configure trunking. So it's basically conf c, you pick the trunking ports on the switches and use two commands, switch port trunk encapsulation .1q and switch port mode trunk. So let's go ahead and get on the switches. So here's VLAN 2, or IOU 2, I'm sorry. So we're going to move that over here. So if you look, it's switch 2 here. The trunking port is E2/0, and the VLAN 20 port is E1/0, and the VLAN 10 port here is E00. So we're going to go ahead and go to conf t. So let's create a VLAN first. So VLAN 10 name. So our computers here are named Mario and Luigi. We have Mario, Luigi, and VLAN 10. So let's name it Mario Bros Net. We can name it that. Exit. We can also create VLAN 20. Now the computers here are named Wario and Waluigi, so we can call it name Wario Bros Net. So that's how you create VLANs. We can actually do show VLAN. And if we move this over here, you can actually see my VLANs are right here. So the 10 is the Mario Bros net and the VLAN 20 is the Wario Bros net. So that's how you can create VLANs. Excuse me, this is locked up. Okay, forgive me for that. There was a little slowdown there. So now after we create the VLANs, we need to next assign ports to them. So int range E0 0/0, sorry, int range E00 to 3. So even though we only have one E0/whatever port, we're going to configure all three, and you probably will do this in your lab as well. But anyway, so the first command we need to do is switch port mode access, because these are going to be VLAN ports. We want them, or yeah, they're not going to be trunking cables, so we want to configure them as access ports. So next command is, let's see, switch port access VLAN 10. So this is the E00 and yes, VLAN 10. So we do exit int range E1/0 to 3. Now we want them to be access ports again. And we want to do assign them to VLAN 20. So that's all there is. That's all there is to creating VLANs. And we're going to go ahead and save our configurations. What's the lag? Once the lag stops. So anyway, as you see here, that's all there really is to creating VLANs. You just name it, you configure a range, you make these ports access ports, and then you assign them to a specific VLAN. So let's go ahead and save. Copy our UST. Yeah, please make sure you use this command to save your work, by the way. So next thing to do is do the same thing on the first switch. So we're going to go ahead and configure the other computers in VLANs on switch 1. So VLAN, we're not going to name these over here. Actually, let's go ahead and do that. VLAN 10, name Mario Bros Net. Bros Net. Oops, forgot the name command. Okay. So exit. So we're going to do int range E00 to 3. We need to make them access ports. Then we need to assign them to VLAN. So this is the E00 ports. We need to be VLAN 10. Int range E1/0 to 3. So switch port mode access. We're going to go ahead and save. So we can actually check our work with the show VLAN command. I'll actually show you that. So actually there's another command too, show VLAN brief. And we just get a very basic listing of the VLANs. So we have VLAN 10 here. It has these ports that we need them. We have the ports we need in it. And then we have the VLAN 20. So let's all go ahead and check VLAN or switch 2 as well. So we named them this. You see they have the same names here. So on switch 1, it's Mario Bros Net, Mario Bros Net. Same here. So these are the same VLANs on different switches. Now, this will likely fail, but let's go ahead and try to have the Mario computer connect to the Luigi computer. Now you see here it doesn't work. The reason is because we don't have trunking configured. So there's two VLANs between these two switches, but without trunking in the 802.1q protocol, the switch doesn't know how to get this information to the Luigi computer. So it's likely it's trying to get to the native VLAN, but the Luigi computer isn't in the native VLAN. So to address this, we need to configure trunking. So conf t. Now trunking is configured on the port that connects the two switches. So that's E0/2. We don't need to do multiple. So int E2/0. Oh, some more lag again. Okay, sorry about that. So int E2/0. Now there's two commands we need for trunking. Switch port trunk encapsulation .1q, switch port mode trunk. Those are the two commands we need. We can actually do this. Switch port mode trunk. Oh, port. Let me see that again. Switch port trunk encapsulation .1q. Maybe you do need to do that command first. Okay, let's try this. That switch there. So as you see here, you can't do the mode trunk command first. You need to do switch port trunk encapsulation .1q and then switch port mode trunk. You need to make sure you do the encapsulation command first. Not sure why, but switch will reject it if you try the other way around. So oops. So let's get rid of that here. Okay, now let's go ahead and configure trunking on second switch. So switch port trunk encapsulation .1q. switch port mode, trunk. Okay. We have everything saved. Okay, now ping should finally work. Let's go ahead and check that. There we go. Now the ping works. So that's really all there is to setting up VLAN. So basically you set up access ports for the switch ports that are connecting to PCs. You create the VLANs and give them a name if your lab assignment tells you to. And then you configure the interfaces to be assigned to that VLAN. And you do that for all the computers and switch interfaces that are connected to computers. And then finally, you configure this one cable between the two switches as a trunking cable. So that's really all there is to do. That's all there really is to configuring trunking. Obviously, these computers are in different subnets, so they're obviously not going to be able to communicate with these computers, but these two should be able to as well. We can even test that right here. Ping 192.168.0.2. See? Works just fine. So that's all there really is to this lecture. Thank you all for watching. I really appreciate it, and you all have a good day.